By the end of this video, you'll be able to filter noisy tags much better. As a control engineer, you may have spent many hours trying to tune filters by trial and error. In this video, I'm going to be showing you how to tune them by a better method that will be both more efficient, faster, and give you better results. Very often in a control system, the filter that you'll have is the exponential filter. This is the most commonly used filter in industry. The tags that often require filtering are flows and levels. So we're going to look at how to tune these. Now, one way to do it is to adjust the filter time by trial and error until you get it about right. But this isn't a very scientific method. So let's look a bit deeper into how the exponential filter works. The formula for the filter is P equals e to the minus ts over tf. A p-value of 0 means you have no filtering at all, and a p-value of 1 means total signal rejection. It's an exponential curve, so you go up from 0 towards 1, and values close to 1 will be at the top of the curve. The other terms in the equation are Ts, which is the scan frequency of the tag, and Tf, which is the filter time, which is the number that you enter into the control system to tune the filter. The scan time can vary. It depends on the control system, and even in a control system that has a default setting, there may be some adjustment. In a Honeywell control system, typically the scan frequency is 1 second, but you might have faster frequencies of quarter second or half second, particularly for flows. In an ABB or Emerson system, you need to check again what the scan frequency is, and it can vary. So once you've established the scan frequency, you can then calculate the value for the filter time. What I'm going to show you is a simple table of TF against P for different scan frequencies. By using this as a kind of a lookup table, you can quickly determine how much TF you should use. I've created a free filtering tool. Click the link below to download it. So the first step will be to look at the trend of the tag and see how noisy it is. Once you see how noisy it is, you can make a qualitative assessment and then use the lookup table to select the correct amount of filter time. If the tag is not very noisy, you might start with a filter value of around 0.7 for P. Now this is a kind of a good starting value because the first order lag, if you calculate it, would give you a number of 0.632. As control engineers, we like to round that up to 0.7, and that's where the 0.7 comes from. So that's your best starting value if you're not sure. And values less than 0.7 are not really going to give you much in the way of filtering because you're at the bottom end of the filter curve. So from 0.7 to say 0.95 will be your working range for P. For moderate noise you can use 0.7. If the noise is a bit worse you can use 0.8, and for heavy noise you could use 0.9 or even 0.95. But you could see that by a quick assessment of the trend and by using this table you can quickly arrive at the right number to enter as your first attempt. Then simply trend the tag for a few more minutes, observing the noise, and if necessary make a final adjustment in the value of the filter time. Again, using the table as a guide. Once you get the value for TF, just remember that you need to enter it in the control system in the correct units. Honeywell uses minutes, but ABB and Emerson typically use seconds. So just check which units you need TF in. For more information about our services, go to newlandcontrol.com.